Hello and welcome to another tutorial, and now we're going to look at the access modifiers for member methods and fields, right, or member variables of a class, or basically the idea of controlling who has access to a member. And we said that even at the time of declaring a class, you can basically decide what is the access for this class, whether it's a public class, everybody can access it, or it's a package level access, right? So if you don't write any modifiers for your class definition, it means only that other types or other classes, other types inside the same package can access it, which is a default access for the default access that the Java compiler and JVM look for, right? So the first leftmost modifier used lets you control what other classes have access to a member field. So we said that when you define a member variable or field, and again, member field, again, that's a little bit weird terminology. It should be either member variable, which is formally known as a field, right? When you say field in Java, it means a variable inside a class or a member variable. So member field is a bit redundant in terms of terminology, but that's fine, right? And again, we've seen the declaration of the variables. It has to have a type, could be primitive or a class type or enum interface, whatever. The name has to follow the naming conventions and also the rules that the Java language specification enforces. Java compiler enforces that the name of your variable or field cannot start with a numeric literal like 1, 2, this kind of stuff. The first character has to be a letter, alphabetic character like C. But then even before declaring the type, you can specify the access modifier for this field, right? And the best practice, always set it to private. So in general, there are 4 types of access modifiers for a field in a class. One is public, the other one is private, the other one is protected. The fourth one, you don't actually write anything. And if you don't write any modifier, it doesn't mean that it's public, and it doesn't mean that it's private, right? Neither of them. Instead, the default access modifier, which is when you don't write anything for a field, it means it's a package level access, which means any class or any other type inside the same package can directly access that variable. And again, best practice, declare everything as private. So for the moment, consider only public and private. Other access modifiers will be discussed later. So I'm going to create a new class. Let's call it access modifiers, right? That's the topic. I'm going to have a main method, and actually let's remove let's keep the access, let's keep the main. And so I'm going to say that public int x1 and protected int x2, and then private int x3 and int x4. So let's look at these 4. Now you see the compiler gives me a warning because compiler knows that a private variable can only be ever used in the same scope. So private means you can never use this variable physically outside the scope of the class, right? I can use it anywhere inside the scope of the class, even the main method. So in the main method, now first of all, I'm going to write some stuff here. Let's make sure this public means open to everyone, which means later I'll show you a table that you can also find on if you Google it, for example, on Wikipedia. So which means open, let's say open to same class. Inside the scope of the same class, definitely you can use any members of the class, that's fine. And then same package, right? And other packages, and basically with the introduction of the concept of the modules, right? Now other modules, for example, and eventually everyone, the whole world can access it, right? So the world can access it. So protected, so same class, we can let's also add another one. Even subclasses, right? Subclasses can access this variable and assign new values to it. Basically, subclasses can modify the state of the superclass, because if something is public or protected, the subclasses will inherit these variables, which means these are also part of the state of the subclass. So protected It's open to basically same class, obviously, subclasses, and then same package. And what about other packages? The answer is no. What about other modules? The answer is no. What about everybody, the world? The answer is no, right? So the difference between public and protected is that obviously same class is always true. Protected is mainly used for inheritance, when you want to go inheritance and have access to this variable, but you don't want to open it to public. So instead of public, you set it to protected. So that's the main difference between protected and public, right? Obviously private is not allowed to be inherited, which means subclasses don't have this variable x3 as part of their individual state. Now it's part of, formally it's part of their state because they are inheriting. So the state of the superclass is part of the state of the subclass, obviously, but private means no other class, not even subclasses, can directly modify this variable. Now obviously if you set a setter method, that is, obviously setters are not supposed to be private because that nullifies the point of having a setter method, right? Therefore, if you set a setter method, add a setter method, it means you want to allow other classes to modify the state of this class. But the setter method can also be protected, which means now you're providing a basically means for subclasses to change the basically the private values of the superclass. And we will look at this later, right? So protected, private, it's open to same class again, and that's pretty much the only place that you can use a private method. So it's really about the internals of the class, and it's other classes, other packages, they can never, they're not supposed to be able to access these private members. And later we will see that when you use Java reflection, you can actually access this. So really, if you really try hard, you can you can access even the private members, but you have to use inefficient code, which is Java reflection, and access the meta information of the class. So even the private members of a class, the meta information is still in the meta space of the JVM when you run your application. So JVM knows what are the private members of your class, right? So private is only open to the same class, which means anywhere physically inside the scope of this class you can access a private variable. And here's an interesting example. Here's an interesting example of private. Now remember, I'm writing a code here physically in the scope of this class. Now notice what happens here. I'm going to write a public method, public int add, for example, let's say access modifiers other. Let's say I want to define, if I have an add method, that I pass another type, another object instance of this class, and then I want to return something, and all I want to do, add the x3 from this class to the x3 of the current class and return it. So return x3 plus other dot x3. Now notice what interesting thing happens here. I'm allowed to directly access the private member of this object, right? Which is very bizarre because this is supposed to be private. So why is this allowed? Because this object is of the same type that I'm using here, right? These two are the same type, and for the rule here is that for the type access modifier, I'm allowed to access the private member as long as I'm physically within the scope of the class. So even if this is another object, because it's of the same type and I am physically inside the scope of this type access modifiers, then I'm allowed to directly access private members. This is one of the main use cases of private. So if you define a class that represents, for example, a complex number, a mathematical entity, and then you want to add two of them, the internals are the real and imagined parts are obviously, you define them as private, but then when you pass another complex number to add them together, you can directly access the internal parts or the private parts. So this is one of the main use cases of private members, right, or private fields. So remember, although we're saying that private only we can use it only for the same class or the same type, basically, However, if you have a method that you pass another that pass a parameter of the same type, because we are physically within the scope of this class, we are still allowed to access the private members of another object, a parameter of a method which is of the same type. So this is very interesting. And what about no access modifier? So no access modifier, it's also called default access, and it's only open to obviously same class, and then a subclass in the same package, and then other classes or other types in the same package. All right, so let's see what happened. So it's open to the same class, it's open to the same class, subclass in the same package, and then basically other classes in the same package. So it's open to everybody as long as it's in the same package. So default access or package level access, it means it's pretty much open to everybody who is in the same package, as long as you're in the same package. Remember, the whole idea of the package was to group some related types. Again, I'm using the terminology type, which means group classes, interfaces, enums, everything, records, which are the recent addition, right? So when types are in the same package, it means we want to basically ease or relax the restriction of accessing each other's internals, because that's one of the main reasons we package them together or put the types in the same package, right? That's why if you don't declare anything, if you don't declare any access modifier, it means we are assuming that it's going to be open to everybody in the same package. All right, let's practice this. Now, when I'm in the main method, obviously none of these are static, right? These are all non-static fields or non-static members variables, non-static member variables, which means these all are part of the state of each instance or each object of this class. So whenever I create an instance of this class using the constructor or using the new operator, right? So how do we create an instance that gets its own state? It's using the new operator, and we will talk more about this later. It's you have to call a constructor. If you don't provide any explicit constructor, you get the default constructor, which doesn't take any arguments, right? So we can say access modifiers am equals new access modifiers, right? And basically what I'm doing, I am calling this constructor, which is always explicit, but if you don't explicitly write it, the compiler will add the no argument. So if you don't provide explicit constructors, then compiler Java-C provides a default constructor, and that constructor is always public, right? Because regardless of whether your class is public or package level access, the constructor is like any other method, so it can be public or not. Now obviously if your class is not public, then other classes in the other packages, they can, even if any method or field public, they cannot access the public fields because they don't have access to the type itself. So in order for a class or a type in another package to be able to access your public fields, it has to first be able to access the type, right? And accessing the type means whether it's public or package level access. So a step one in accessing a field is other types must first be able to access this type. For example, this type could be class, interface, enum, anything. And for a type, you only have two options. It's either public or package level access or default, right? All right, so let's look at the, first of all, I've mentioned this before that Eclipse provides this very nice representation, and I've showed you basically this outline, which is a very nice feature. I highly recommend you get used to it. It's very colorful and very nice, and I'm going to repeat again this outline and the meaning of the symbols in this lecture and also the future lectures. So let's see what information this immediately tells us when we open a source file. So it tells me this class, there is a this source file is inside this dev_java.classes. So this is a package hierarchy. So and then every class that we define inside this source file is going to belong to basically this this package, right? So it means this source file belongs to a package. And then we have one definition of a type. That type is green, which means it's a public type. Again, type means class, interface, enum, record, etc. So whenever you see a green, means it's a public type. And it's C, which means it's the type is a class. So it's not an interface, it's not a record, it's not an enum, right? It's a class because it has a C. And this class has a green rectangle, which means it has a public static main method. Main means it's runnable, because when you run the Java application, the meaning is that JVM is calling the main method of a class, right? So you can launch your Java application by running the main method of a class. And so this green arrow means this class or this type, which is a public class, is runnable. Runnable means it has a main method. So I'm going to write it down here. So this class is runnable, which means JVM, so which means you can launch your Java application by calling the main method. Your Java application by basically calling the main method of this class. And we saw that whenever you run a class in Eclipse, it creates a separate run configuration. And run configuration means what was the main method that was used, and what were the arguments that passed to your Java program, the main method, right? That a string array args, right? In the main method, these are, if you write parameters here, they're going to be passed as a string array to your main method. VM arguments, these are the command line arguments. For example, previously in the previous lectures, we saw that when we run Java command or JVM from the terminal, we can pass a parameter like -cp, which determines the class path, right? And Eclipse automatically sets this class path, so we don't need to set it, right? And you see Eclipse also passes two other flags or configurations to JVM: -x start on first thread and -xx show code detail exception messages. For example, the null pointer exception that was enhanced from Java 14, it tells the JVM, hey, show more information about exceptions like null pointer exception, this kind of stuff. It tells you which JRE was used. If you have multiple JRE installed, you can launch JVM from any of them. It shows you the dependencies. Right now I have a class path entries my project, and right now my JRE is part of the class path, not module path. The source, it tells me what were the sources. I have my source projects and also the JRE environment variables. So Eclipse nicely provides a means of adding if your Java application depends on environment variables, or let's say it calls some native code, C++ code that depends on environment variables. Because remember, even when you launch your Java application from terminal already, you can define environment variables for your operating system in the terminal, in that shell session, right? In that terminal session. All right, so okay, so just by looking at the outline of the source code, you know this source code belongs to which package, what types are defined, what is the access modifier for those types, what's actually the type, is it a class, is it an interface, if it's a class, whether it has a main method or not, right? There is also a little yellow triangle. It means there is a warning. It's a compilation warning, which means when Java compiler compiled this type, which is class, there were some compilation warnings. There is no error but warning. And obviously Eclipse has a much nice basically this visualization on which line actually this warning happened. And all that is telling me that, hey, you created this class, but you're never using it. And the rule for local variable, because this AM variable is a variable, has a type, access modifiers, and it's a local variable. And the rule was that if you don't use local variable, you shouldn't actually be defining them, because what's the meaning of having a local variable that you never use, right? That's why the compiler is giving me a warning, hey, the value of this local variable is never used, so there is no point of having that local variable. But I'm going to use it later, so so let's keep it for now, right? So that's it. So class, it's runnable, it has a main method, there's some compilation warning. And now when we collapse this, we see that there are four variables and two methods, right? How do I know x1, x2, x3, x4 is variable? Two ways. One, methods have, after the name of the method, there is a pair of round brackets which defines which parameters that method takes. Obviously, none of these take any parameter, which means these are not methods. Even a method that doesn't take any parameters, it has an empty pair of round brackets. So if I have a method public void do nothing, so this doesn't take any parameters, its return type is void. And you see for the methods we get an empty pair of round brackets, which means this is a method, this is something that takes parameters, which is the definition of method. And for method, it tells me the type of return values, which is very handy. So I can immediately see if I call this method and pass an argument of this type, what is the return value, the type of the return, right? Any method has to have a return type. The compiler needs to know that type, right? And all of these methods, obviously main has to always be public static, S means static, and it should take a type of a string array, and the return type of the main should void. And this is mandatory. So if you want to launch your Java application, you have to have this signature for the main method. But besides that, I have two other methods. They don't have S, so this means these two are not static methods, right? And obviously I can see the name of the method, the type of parameters, and also it tells me this is green. Green means these are public methods, right? What about the fields? So the difference between public field and a public method is that fields have a white dot in them. So this is the second way that you can immediately figure out in the outline whether it's a field or a method. All the fields have a white dot in them. Methods don't have a white dot in them, right? So this is a public method is a full green circle. Public field is a green circle that has a white dot. So these four are fields. And again, we mentioned that the best practice in Java is that you always list all the fields before the constructors, and after that you list all the methods. So usually the declaration of the fields of the class come all at the top. Remember, that's not a requirement. So I can have here after this method and main method, everything, I can say public double y. This is allowed, and Eclipse actually shows it exactly where it happens, right? Sure. But then there is a way to tell Eclipse to actually not preserve the order. So if let's see, yeah, so this one, if we click this one, it sorts them, and the way this sorts happens is that it puts the main method at the top, and then all the fields are come after each other, and then the main method. And again, this is the convention that we typically have, right? So if we don't say the sort them, then it just shows the fields and methods the same order that they appear in the source code. But if this bothers you, and if somebody has written a source code that has lots of fields defined in various lines after methods, after constructor, and you just want to quickly look at the outline, you can click on this sort button, and it puts all the fields together. The static methods come at the top, non-static methods come after all the fields are listed. So this is a quick way of asking Eclipse to sort them so you can look at the fields, right? All right, so what I wanted to show you here quickly is we're going to look at this accessing these fields in the same class, and in the next lecture we're going to look at accessing the fields from subclasses, classes in the same package, other packages, etc. Remember, in the main method I have to create a new instance or new object of the same type, right? Now this is like a local variable in this scope, but I am still physically within the scope of the type, this type, right? So I can say am dot so sysout am dot x1, right? This is allowed. So let's also initialize them with 1 2 3 and 4. So this is allowed. So public, no problem, we can directly access it with a dot operator. am dot x2, So protected, we can access it, no problem, no compilation error. am.x3 private, right? Private, we are still within the scope of the type, so we have no problem directly access the private. And then sysout am.x4. So no access modifier, which means package level access, no problem. We're in the same type. So as long as you're in the scope of the type, you are allowed to access everything, because these fields belong to the type. So even if a type cannot access its own state, then what's the point, right? So so this is true. And let's also quickly let's check this point by trying to create an instance of this class, which is a public class, in another package. So access modifier demo, and we're going to have here. So in the main method, I'm going to do the same thing, and right now we get compiler error. Why? What's going on? So so we're defining a type, right? Obviously I'm not, because I'm in the same package, I have to use the fully qualified name. But Eclipse, when you copy and paste a type, Eclipse is very smart to automatically add the import for the fully qualified name. So that's why I'm not using the fully qualified name. So if you are not familiar with this concept, go back and review the lectures that I had on the packages, because that's a very, very important topic, why we have to use fully qualified names and what's the meaning of import, right? But as you can see, now there is a restriction. And so those restrictions that we had on the definition of access modifiers even apply to the same type. I'm creating a class of the same type, but in a different package, and I'm allowed to access public is no problem, because I'm in another type, in the scope of another type. And the question is, if I have a class, what part of its fields, what part of its state I'm allowed to access. Remember, I mentioned that a type has to be able to access its state, but it's only true as long as you're in the scope of that type. If you're in another class, which is in another package, then all the access modifiers rule apply, which means this class, another class like access modifier demo, can always create an instance of other types like access modifier. But then when we want to access the state of this variable, the question is which parts are we allowed, and that is based on the access modifier rules for the state variables. So x2 was basically protected, and we said that protected is only open to same class, which means we are in the scope, and the subclasses same package, that's it. But right now I'm in another package, right? That's why the protected is not allowed. So protected basically allowed in other packages. Public is allowed, protected is not allowed in other packages, but it's allowed to subclasses in other packages, and that's what we see in the next lecture. And x3 was private. Obviously private is never allowed in other types, in other class, whether it's in the same package or not, doesn't matter. Even if it's a subclass, it's also not allowed. Private never allowed. Remember, we are trying to access the state of this object, which is of type access modifier. So basically the concept of access modifiers is that if inside another class we create a variable of this type, which part of the state of this object are we allowed to directly access? That's the meaning of access modifiers. And no modifiers or package level access, then this is also not allowed in other packages, because x4 didn't have an explicit access modifier, which means only classes in the same package are allowed to directly access it. All right, so this was access modifiers, and also testing it in the same class, in the scope of the same class, and in the scope of a class that is inside another package. In the lecture, we tested in 3 other different scenarios, right? One, a class in the same package, a subclass in the same package, and then a subclass in another package. So 3 more scenarios to check. One is a class in the same package, 2, a subclass in the same package, and then 3 a subclass in another package, right? And right now we're assuming that this class, this type, is public, so open to everybody, but we are just concerned with the state of the class, right? Who's going to access which part of the state. And when we say other, who's going to access it, which means if somebody else creates an object of this type, which parts of the state of this object, because other objects can have this variable, have this type, variables of this type, as local variables or as variables of their own, right? This class can have actually a variable which is part of the state. Remember, this a variable has to have a type, but it could be another class, but this variable belongs to a state of this class now, right? But then because there is some rules applied to the state or the variables that build or create the state of this object, this type, then this class, even though it owns this variable, it might not be allowed to directly access the state or part of the state of this variable, this object, right? So again, that's the meaning of access modifiers. So I hope you understand this. I will come back to this in the next lecture, and we will have more discussion about it. So please stay tuned, and I'll see you in the next one.